Is this thing on? Yeah, I think it's on. Okay. Last thing, or actually, first thing. I know you haven't watched, or you shouldn't have watched the lecture on clutches and brakes yet, but there's something that I didn't make very clear in the real lecture, and I just want to make sure I get this clear. So typically there's a ring of friction material, right? A brake or a clutch does basically the same thing. It's a frictional interface between something that's rotating and something that's not, right? All right, and it has this ring shape. And there's something very counterintuitive about how the braking torque or power transmission torque is related to the inner and outer diameters, right? And you'll get to that, in the lecture. Let me back up a little bit and say that the friction material, it used to be asbestos, some sort of ceramic, some sort of composite, woven composite with some polymer, something like this, right? Well, the limiting factor of these friction materials is oftentimes the maximum pressure, right? The harder you can squeeze on this stuff, the more torque you can transmit or the more effectively you can brake. But you can't just wail on it as hard as you can. There's some limit. There's a maximum pressure. So oftentimes, the limit of the springs you can use to compress these two plates together is the maximum pressure that this friction material can withstand. So many of the relations are assuming a constant pressure. Holding the pressure constant, what happens when I make the outer diameter bigger? What happens when I make the inner diameter bigger? Okay. So it's really, really important to remember this. That are we talking about a constant force? If I increase the area, the pressure goes down. Or am I talking about a constant pressure? I've selected my springs and designed this clutch in such a way that I'm always right at my the maximum pressure which the material can withstand. So that's the important thing. Remember the difference between maintaining a constant force, changing the area, the pressure changes, or changing the force to maintain a constant pressure regardless of the area. Okay, so constant pressure versus constant force. Take a minute or two to derive these equations, or at least to look through the derivation, so you make sure you can keep those straight, because it's a little counterintuitive either way you do it. That's it. Enjoy the show.